Hey guys, welcome to Quinian's Budget Crafts. I know it's been like 3 weeks since I posted a video. I've been really busy modeling Kimberly's dragons for the next Kickstarter. The picture's somewhere. Here's some pieces. I had to model it and then test print all the stuff or whatever. It's going to be a lot of dragons, like 4 dragons. They're all in pieces, so you can print them on little guy like that one back there, which is what the noise is. Speaking of Kimberly though, her sewing machine broke, kind of. I was looking at paint mixers because I have more paints now, and they're really, really expensive. So when this thing broke, it wasn't all bad because the motor does still work. So I think, with some tinkering, I can probably take it apart, salvage the motor, and turn that into a paint shaker. I don't know if it'll work, because obviously I haven't done it yet, but it's going to be a video either way. Alright, so let's take this cover off. Speaking of the cover, though, I don't know if you guys ever watch Adam Savage. If you don't, you totally should. He models a lot of stuff out of polystyrene, which is similar, if not actually the same thing, as the stuff they use for this cover. So I'm going to keep this because I can probably do something with that. So the machine itself, if you don't know how sewing machines work, it's pretty simple. You plug them into the power, you push the button, and the needle goes up and down. First though, let's get this apart and see about stealing the motor and whatever else we can. Alright, so the first thing when working with electronics is unplug it. Make sure that it is unplugged. If you can unplug it from the machine, definitely do that. If you cannot, then make sure it's unplugged from the wall and cut the cord if you have to. After you've done that, you can go ahead and just start pulling out every screw you can find, and it should come apart eventually. Sometimes they rivet these things together, but not in the case of the sewing machine. If it is riveted, it's probably just soft plastic. You can get a flathead screwdriver in there and break it apart. Something else you're going to want to do is make sure that you keep all of the screws and washers. And once you get the shell taken off or the thing split in half or whatever the case may be, you can just go ahead and start taking components out. A lot of these components you can probably salvage for other things, like right here I've found some working LED lights, so I'll definitely keep those. There might be some gears or linkages that you want for things, or it's just stuff that looks interesting for a project. So this thing right here is the front LCD panel that tells you what numbers you're on and all that good stuff. I don't have any way of repurposing this because I don't know how to program boards, but somebody who's good with like Arduinos or that sort of thing could probably make use of this. For me, it's going into the electronics waste pile. But while you're taking something like this apart, what you're going to want to do is separate the electronic scrap from the metal scrap and the wiring harnesses and the plastic scrap. When you get to the components that have the power supply on them, you're going to want to check around for like capacitors and stuff. That's those big barrel looking things most of the time. I don't know if this particular device is going to hold a charge. I'm not sure how long capacitors can, but just in case, don't zap yourself. So in our waste piles here, we have the big pile of plastic crap. We have the lid that I'm keeping for other stuff. I'm actually going to use the corners of it in this build, you'll see. The thing is screws and washers there. There's some smaller chunks of plastic I ended up breaking in that hot chocolate tub. These here are the electronic waste bits. That thing there is the capacitor, the big round thing. And then the wiring harnesses are bundled separately. I don't know why, but recycling guys prefer when you do that. And in my pile of metal salvage, I ended up with some long rods that are pretty cool. Got a couple gears. I separated the springs because I want to keep those. And there's a bunch of miscellaneous bits that I'm not going to use, so they're going into the metal heap. Alright, so to take this lid thingamajig apart, I'm just going to go ahead and use the jigsaw. It's super noisy. Make sure you keep your hand out of the way, don't cut yourself. Once you've essentially broken the structural integrity of this, you can then score it with like a box cutter and just snap it. But until you actually get, some of that apart, it's probably not going to break. I'll just set these panels aside for something else, and right now what I want is the very top of this lid. So this here is the motor that I was actually after inside the machine to start with. I just held that up to the plastic to see where I need to cut it, like how wide that mount is, and then try to mark that. I have this thing here, I'll put a link to it down below. It's a 45 degree, 90 degree angle holder pincher thing, so some kind of vise. It's actually pretty cool. It's not what it's meant for here, but actually it worked really well because it's just about the right size anyway. I just put it in there and then use that to mark pretty much even sides, how much to cut off. It's not perfectly even, I'm not super worried about that at this stage, I'm just trying to get it trimmed down. Then I went ahead and used the square to transfer the marks into actual lines so I know exactly where to cut. And then held them up next to each other and double checked that the lines actually do match. One of them didn't, so I just scribbled it off and then went with the larger of the two. You can always cut more off later. You can't really add anything back, so always better to leave more on there than you need to. To mark the height of these things, I figured out about how high they need to be based on the motor, and then propped up a little box so I could set my pin on it, and then just spun the lid around to mark the thing all the way around evenly. And this will keep the mark level with the actual top portion of the lid. That'll end up being the top portion of the housing for this thing when we're done. That way it'll sit nice and level. And now, using the world's scariest Dremel tool, I'll go ahead and cut that out. It is pretty important to try not to melt this plastic because it's pretty stinky and probably toxic. Once you get them roughly cut out, you can go ahead and stand them up to try and see like how they fit together. You're gonna have to work out some kinks to make it fit. Depends on exactly what size you're going for and that kind of stuff. In my case, I just kept cutting off pieces until it fit properly. I would get one piece to be really nice, and then I would match it up with its neighboring piece, cut that, and then use the second piece to match up with the third piece, and so on until it all worked. If you make sure to stand them up on the lid portion so that the housing's upside down, that way you can make sure that it actually is matching, like the walls are matching, because you don't want to match them to the bottom of it yet because it's probably not flat, but the top of it is, so measure off of that. That'd be kind of boring to watch though, and it took a very long time, so I'll just go ahead and skip ahead a little bit here. Once you got it all fitting together pretty well, you can go ahead and glue it together. I just used a bit of crazy glue on the outside, and then I used some of the Tester's model cement on the inside because that stuff actually melts the plastic together. Don't worry too much if your seams are rough, we're gonna sand this thing down later. But before we sand it, let's go ahead and figure out where we want to put some holes in this thing. For the button there to go ahead and turn the thing on, I'm using a momentary switch. It's actually rated for AC current and stuff, but it works fine for this small DC motor. All I really did to figure out the placement is just put my thumb there just to see what felt most comfortable, and drill a hole out right there. Using a step bit is pretty helpful, that way you don't have to keep switching different drill bits, because you don't want to go too big to start with or you'll just shatter the plastic, but if you go too small then you gotta work your way up, and it's annoying. Step bit will just step it up for you. As for the hole in the top for the motor shaft to stick out of, just drill that dead center, or as close as you can get. So as for a motor mount for this thing, I really wanted to just, whip something up in 3D, but trying to keep it accessible for everyone. If you bust into a lot of the older electronics or like really cheap ones, the motors and stuff are mounted to a really cheap wood frame that's been stapled together, so I'm just gonna do the same exact thing. These are the large square dowels you can get at Walmart. There's a pack of assorted ones, like 15 of them in there, different sizes. Just glue them together with some super glue wood glue because it dries fast, and staple it together. As far as the sizing and stuff, just hold it up to the box and keep trying until it fits. In my case, because the box is rounded, I actually had to round the edge of the bottom of the frame too, but that's no problem. To figure out the height of the upright, so just put the bottom of the frame in there, put a stick in, and then put a mark on it where it meets the frame. These uprights actually hold the motor though, so I went ahead and drilled through both the frame and the center of the upright and put a big screw in there just to make sure it's not going to go anywhere. And then I put a couple of 45-degree angle supports on there. The Sure Bonder staple gun can also shoot brad nails, so that's what I did. I put the brad nail in and had to hammer it the rest of the way because it wasn't going to go through that. It's some pretty dense wood actually. And then just more of that super glue wood glue on all the joints to reinforce them. The motor needed a couple little spacer blocks between it and the rest of the frame because it's the frame sits too far back in the case there for it to put the motor in the center. So these little wannabe Jenga blocks from the dollar store, they work really well for this kind of thing. They're actually the perfect size. So I just put a couple of those on there and put a hole through them to mount the motor with. For mounting the motor, I've got some bolts. I have no idea what they're from, probably a vacuum cleaner or something. Seriously guys, save all those parts. You never know when you might want them. And then that mounts on and fits on pretty well. There's a little gap on the bottom, but I haven't quite sanded that yet, so that's looking pretty good. After sanding, I'm going to spray this with some primer filler to clean up some of the more nasty spots, spray it with bright silver spray paint, and then a gloss black. That way if I want to scratch it or something, it looks like it was metal originally. For the electronics on here, huge thank you and shout out to Bluestreak Customs who helped me once again with the electronics. Like I knew what I was doing, kind of, but I wanted to confirm. I did need to pick up an 18 volt DC power supply because that's what this motor is. And the one I picked up happens to have a cool little thing where you can just put bare wires in there and screw them down. Before we solder anything though, we're just going to have all the connections together and give it a test to make sure it works. Let's just go ahead and test it out. And then for the arm, I did try to make a little offset arm kind of thing, kind of like the vortex shakers have inside of them, but this happened. Turn the speed down just in case. That's too much weight. Yeah. Okay. So yeah, like I said there live, that was too much weight. So, well, let's rethink that thing. But I do know that the electronics do work, so I went ahead and soldered everything up. So, rotational arm take 2. I didn't think to film the making of it because I don't know. Anyway, it's just a whole bunch of pieces of the sewing machine cover plastic that's been glued together and shaped into this neat little shape. That one definitely did work with a lot less, jumping across the table, but it still had problems. We'll get to that in a second. First though, I went ahead and glued everything into the housing here. I made a little hole for the plug to go into and then glued that thing into the hole so it would sit nice and flush with the case, and then poured a whole bunch of hot glue all around anything that wasn't important. Basically just wanted to hold it in there, and then the hot glue itself is almost like a rubberized material, so it will absorb some of the vibration. Something else I salvaged from who knows what, some kind of build it yourself furniture. It's a bunch of those little felt pads that stick on to the bottom of something. Went ahead and stuck those on the bottom here after sanding the bottom nice and flush. That way, it's got some more shock absorbent on the bottom. Now that everything's soldered and glued together, let's test it and make sure I didn't mess something up. Plug it right into here. Adjust this to whatever speed you want. Still working. So here's the take 2 arm. I got one of those little cups, like you get from like the egg machines. You put 50 cents in there, it's got a stupid toy in it. I use that for the little cup holder to hold the paint bottle while you're spinning it, and it does this. Gotta hand it to the engineers who make the vortex. They definitely know what they're doing and I don't. So, quick fix on this. I'm just gonna go ahead and cut this thing down. I tried simply removing the paint cup and then leaving the hole so that I could put the tip of the bottle in the hole and it would jiggle it around in a circle that way. It didn't really work. It'll either throw the paint bottle out of your hand or you just stop it from working altogether because this motor has essentially no torque. What I did discover by accident though is that if you put the paint bottle right in the middle there, you can get it to spin, and it works. You just kind of hold on to it loosely so that the machine can take it from your hand and spin it. Well, it may not be as 100% as effective as the like $300, lab mixers. It definitely does work. So if I take this one here, that's supposed to be gray. The bottom looks like to be some kind of green sludge, and the top is blue. I don't know why. And go ahead and stick that in there. And there we go. It's nice and mixed now. So yeah, that definitely does work, and you can adjust the speed on it with that plug that I got. I'll link that below too if you guys wanted to do the same thing, or you need a DC power supply for some reason. So maybe not what I had in mind when I first started, but I'm definitely happy with this build. Got an adjustable speed power supply. It plugs into the back nice and clean. Got the momentary switch. It was almost free, not counting the cost of the power supply. And it doesn't really take up any room on my desk. As for arm take 2, the little piece there does actually come off of the motor shaft if I wanted to revisit this later and try to get it to spin properly, but for now, I'm actually happy with this, so I probably won't mess with it, honestly. And I do have other motors from things I salvaged, like I mentioned, a vacuum cleaner. Thought maybe about making a lathe out of that, something like that, I don't know. If you guys want to see me do more kind of salvage builds, let me know and I'll see what I can do. But of course, as always, thanks for watching. Don't forget to like, share, comment, subscribe, and I'll catch you in the next one.